I will be telling you about the technical approach of the project. My name is Kritika Sharma and 0801CS221075 is my enrollment number. So, overview of the technology stack. Key technologies: front end HTML, CSS, JS, OCR engine, Tesseract.js, file handling, Excel, SX.js for Excel manipulation, backend, REST API for data saving via JavaScript Fetch API. Objective: to develop a web-based solution that allows image upload, OCR processing, data extraction, and Excel storage all within a user-friendly interface. Front-end HTML, CSS, and JS. HTML structure to the web interface provides tag for field input, image preview, and data display. CSS styling for visual appeal and responsive design ensures a clean, intuitive user interface for users of different skill levels. JavaScript core functionality for handling file input, processing OCR results, extracting data, and saving to an Excel sheet. Manages the display of messages to keep the user informed. Why Tesseract.js for OCR? What is Tesseract.js? It is a JavaScript based optical character recognition library that can process images to extract data, works directly in the browser, eliminating the need for server-based OCR processing. Why Tesseract.js was chosen? Browser-based, runs directly on the client side, which simplifies the system and removes the need for a complex backend. Accuracy: Tesseract is one of the most accurate OCR engines available for general purpose text recognition, open source, free to use, and widely adopted, meaning ample resources and community support. Alternatives considered: Google Vision API, more accurate but requires network calls to an external API, which adds latency and costs. Microsoft Azure OCR, powerful but cloud dependent, which makes it costly for frequent use. OpenCV with Python, effective for server based applications, but not feasible for a fully web based solution that operates solely on the client side. How Tesseract.js works in this project. Image input. The user uploads an image of the admit card OCR process. Tesseract.js reads the image and performs character recognition, extracting text based on its pre-trained language models. Post-processing, the extracted text is then cleaned and processed to locate specific information. Why this works well. This system doesn't require high processing power or internet for cloud OCR, making it efficient and user-friendly for institutions. Why is excelSX.js for Excel file handling? What is excelSX.js? A JS library that can read, manipulate, and generate Excel files, ideal for handling data in tabular format directly in the browser. Why was it chosen? Client-side processing allows the data to be stored or modified without server-side intervention. Excel compatibility, widely compatible with standard Excel software, which makes it easier to manage the recorded data. Open source and lightweight, easy to integrate with comprehensive support for common Excel operations. Alternatives considered. Sheet.js, the paid version of it offers more features, but they are unnecessary for the project scope. Server-side options, Node.js plus Excel.js. This would complicate the project by requiring server-side support, which is not needed in purely client-side application. Why it works in this project, how it works in this project. Data extraction. Name and enrollment number are extracted from OCR text. Data insertion. The extracted data is inserted into a new row of an Excel file within the browser. This process ensures that the data is readily available and accessible without extra steps. File export. Once the data is added, user can download the updated Excel file or save it directly, keeping records updated efficiently. Why this works well? Eliminates the needs for backend processing while still allowing data to in a universally compatible format. Why JavaScript Fetch API for data saving? What is Fetch API? A modern JavaScript API for making asynchronous HTTP requests to the server. Why Fetch API chosen? Asynchronous. Handles HTTP requests non-blockingly so users doesn't experience delays. Browser compatibility supported by most modern browsers, ensuring the application works for a broad audience. Simplified syntax, easier and cleaner code than traditional XML, HTTP requests making maintenance simpler. Alternatives considered. Axios. Popular but adds unnecessary bulk for the small scale project. XML HTTP request. Older API, more complex system, more complex syntax, and doesn't offer the same simplicity as Fetch for modern JavaScript. How technologies work together. Step by step process. Step 1, user uploads an image. Step 2, tesseract.js processes the image and extracts text. Step 3, JavaScript parses the text to find specific information like name and roll number. Step 4, data is added to an Excel sheet using Excel sx.js. Step 5, the user can save or export the Excel sheet for record keeping. Benefits: simple client-side processing. Second, quick and effective data handling, reducing the need for complex backend infrastructure. Conclusion summary. Tesseract.js and XLSX.js were chosen for simplicity, efficiency, and compatibility with a client-side web-based solution. Impact. This approach enables a fast, accurate, and reliable exam entity verification system that requires minimal resources and offers high accessibility. Future enhancements. Potential for cloud integration or hybrid approaches for larger scale deployments. Improved OCR handling for specific admit card layouts and variant languages.